Alright, here's our Unit 8 review, which is a review of all sorts of things about graphing parabolas. So, we're going to start off with some vocabulary here. If a function has an x squared as its highest power, the function is called quadratic, as opposed to something that's linear whenever there's a first power as its highest power. The highest or lowest point of a parabola is called the vertex. We could also say it's our maximum or minimum value, or that it's our turning point. Those are all other ways of describing the vertex. The line that splits a parabola in half is called the axis of symmetry, because if you make a line through the vertex vertically, then the parabola should look the same on either side, as though there were a mirror in the middle. Number 4, the name we give to the graph of a quadratic function is parabola, and you should have been able to figure that out, if nothing else, from the fact that I used parabola in these two other questions. So it doesn't hurt to try to use the test to help you take the test. And then number 5 here on mine was just the answer bank or word bank for the first 4. Number 6, this is something I like to do occasionally, is there's a formula that we need for this test, and so I will willingly tell you whether you're right or wrong during the test, and if you're wrong, give you another shot at it, and then if you're still wrong, then I'll give you the correct formula, but count this question wrong right then instead of waiting until later. And so the bright side is that you'd at least have the right formula for the rest of the test. The formula that you use to find the vertex when you're in standard form is negative b over 2a. That negative could either be in front of the whole fraction like this, or you can put it on the top with the b like this, and that's fine. You also technically can put it on bottom if you really want to, although I don't know that I've ever really seen people choose to do that. What you would not want to do is put it on top and bottom, because then those negatives should cancel out, and that's not what you're trying to do. You want your answer to be the negative of whatever b over 2a is. Now we have that formula, and we're going to use it in a couple problems. These 4 questions ask us to identify the vertex, axis of symmetry, and direction of opening for each of these, and they don't give us a graph, although we could try to graph it if we really couldn't remember how to do it any other way. Also, these first 2 are in vertex form, and the second 2 are in standard form, and that's going to change how we approach them. Vertex form, the vertex is staring us in the face, so we don't have to do any work whatsoever. We do have to remember that what happens inside of our parentheses is the opposite of what we think should happen, because what's inside is part of the super secret opposite society. So this plus 3, which is affecting x, and x is left or right, this plus 3 isn't telling us to go right 3, it's actually telling us to go left 3. So our vertex is negative 3, comma, and the 2 on the outside is telling us to go up 2. I don't know why I put the plus sign, I don't need that plus sign there. It's telling us to go up 2, so negative 3 comma 2 is our vertex, because normally it's at 0, 0, but we're moving it left 3 and up 2. So it's just the opposite of what's inside the parentheses, and it's the actual thing. Did I say outside? It's the opposite of what's inside the parentheses, and it's what's actually outside the parentheses. The axis of symmetry, which I'm going to abbreviate AOS, is x equals the x part of your vertex, because if you're imagining your parabola and here's your vertex, the axis of symmetry is this vertical line that goes through it. But our axis of symmetry is a line, a vertical line, so it's x equals whatever this x value is. And I, at least, am really picky and count off for not writing x equals and just writing negative 3. And then the direction of opening comes from the very beginning. If what's in front of my parentheses is a positive or nothing, then this should open up. If what's in front is a negative, then it opens down. So since there's not anything in front of this parentheses, that implies that my parentheses is positive, so this opens up. On number 8, same deal, also in vertex form. So our vertex is this and this, And I was paying attention to other things, so actually these two problems are really similar. It's also -3, and then it's -2. You switch the sign inside but not the sign outside. This -3 in front does not affect our vertex. The -3 in front helps us know that it opens down, and if we were trying to graph it, we would know that it's a vertical stretch of 3 because of that 3 in front. Our axis of symmetry is also not affected by the -3 in front. It's just this +3 inside, which we change with the super secret opposite society. If it's in standard form instead of vertex form, we have to start off by finding the vertex. And so we use the formula that I wrote down up above, -b over 2a. And we label these numbers. We have 3 numbers here, so we label them a, b, and c. If our function is in standard form, meaning x squared, then x, then nothing, then it'll go in alphabetical order, which is nice. So I'm going to do -b, and b is 4, over 2 times a, which is -2. So what you want to do is the bottom here, which is 2 times -2, so that's -4, and then divide. So multiply on bottom and then divide. And either look at your negatives at the beginning and decide what your answer should be, or keep track of them along the way. And what I mean by that is I can already say negative divided by a negative is positive without having to know what number it is. Or I can keep the negatives with it right here and say, okay, those negatives cancel out and it leaves me with 1. That's our x value. Now we're going to plug that in and figure out what our y value is for our vertex. So I'm going to put it where both of these x's are. -2 times 1 squared plus 4 times 1 minus 6. So 1 squared I do before I times by -2. So 1 times -2 is -2. 4 times 1 is 4. This is going to happen every time when you're plugging in to find your vertex. This middle number should be twice as much as your first number, but they should be opposite signs so that you'll always subtract them in some way. -2 plus 4 is 2, and then 2 minus 6 is -4. So our vertex is 1, -4. Our axis of symmetry is x equals 1. And this does the same thing as in vertex form. You want to look at the very first number, this -2. Since it's negative, that means it opens down. So that's our 3 pieces of information. On 10, we've got a, b, and c again, although there's not a number in front of x squared, which means that number has to be 1. We just are lazy as mathematicians, so we don't write it down. So I'm going to do -b over 2a. It doesn't matter if you put the negative in front or put it on top. I think it's actually a little bit easier to put it on top and then just immediately have whatever that number is change signs. Or I actually think the easiest way to do it is say, oh, I only see one negative, so that means my answer is negative. 2 times 1 is 2, so -2 over 2 simplifies to be -1. I'm going to plug this -1 in to my parentheses, and if you are trying to plug this into the calculator, or even if you're doing it yourself, it's really important actually for you to think about that I'm squaring a negative number and what that does. So I've got myself a calculator right here, and if I type in -1 and then do squared, the calculator thinks that I asked it what's 1 squared with a negative in front, which is -1. But what I wanted to ask it, that's not what I meant to press. What I was trying to ask it was, if you have the number -1 and you square it, you get +1, because -1 times -1 is +1. And so if you are able to use your calculator, it's really important that you are really careful with how you type it in. If you're using your calculator, the other thing that you need to know is it thinks that this button at the bottom close to enter and the decimal point that says negative is different than this button on the right side that says negative. And so you want to think of this one on the right side as when you're minusing things, you use it. But if you're putting a negative in front of a number, you want to use this bottom one. So I would type, if I want to type in that whole line, I would type in -1, and then this x squared button puts the squared, and then I'd do +2, and then I'd do -1. I technically don't have to put parentheses here, but if you just get in a habit of putting parentheses around all your negative numbers, it'll actually make things easier in the long run on your calculator. When I press enter, it tells me that is 2. And what's neat about typing it all into the calculator is that then you could scroll up and you could edit this and just change what number you plugged in. Like if you realized -1 wasn't right, you could go in and change it and not have to type the whole thing back in. Or you could scroll up and see what your previous answers were. Alright, anyway, we got 2 for our y value. So the vertex here is -1, 2. And our axis of symmetry is the x value, so x equals -1. And our graph opens up because this is a +1. Now let's get to sketching some graphs. So there's 2 ways to try to graph parabolas, no matter which form you're in. And I've got 3 here that are in vertex form and then 3 that are in standard form. All of our forms are, what's most important to us is going to be getting the vertex. And that's going to be different depending on which form it is. But after we find the vertex, we actually can use the same method either way. One method is making a table of values, and the other method is to use transformations. So I'm going to show both of those so that you can see. So on 11, we find the vertex by using these 2 numbers. Remember, it's the opposite of what's inside, and it's what the outside actually is. And we ignore the 1/2 whenever we're finding the vertex. So we're going to plot 2, -1. Notice that each of these squares is only a half, so we have to go over 4 to get to 2 and down 2 to get to -1. To graph the rest of our parabola, we either want to make a table of values, and if we make a table of values, we want to put our vertex in the middle and then pick 2 numbers up above and 2 numbers down below, and then plug these in where x is and work out what that is going to equal. And you actually only have to do either the top 2 or the bottom 2 because it should mirror onto the other side. What that's going to look like if I plug in 1, for instance, is 1/2 times 1 - 2 squared minus 1. Now you can type that into your calculator if you're allowed to use one, or we can work through the order of operations. We'd start with parentheses. 1 - 2 is -1, and then I need to do the exponent. -1 squared is 1. And then I do multiplication. 1/2 times 1 is a half. And then a half minus 1 is -1/2. And that's going to be both of the 2 things that are closest to it. Then I could plug in 0, which 0 is usually a pretty easy thing to plug in. Although it's even easier in standard form to plug it in than in vertex form, because here 0 - 2 is -2, and -2 squared is 4, and 1/2 times 4 is 2, and 2 minus 1 is 1. And so I can graph these points that I've got and make my parabola. That's if I want to use a table of values, and that's kind of your backup surefire way to do it, assuming that you can actually plug numbers in and figure out what they are. The other way to do it is to use transformations. Now, this requires us knowing what a normal parabola looks like. So a normal parabola starts at 0, 0, and then the next 2 points are up 1 and out 1. And then the next 2 points from the vertex are up 4 and out 2. Now I've been working with my students a lot about this pattern. So it's up 1, out 1, up 4, out 2. And then we use the idea of this 1/2 to tell us what we should do instead. So instead of going up 1 and out 1 from my vertex, which is here and here, I want to go half as far from my vertex. So that puts my dots here and here, because this is half as far from this line where my vertex is as it would have been if I'd gone up 1 and out 1. And then instead of going up 4, 1, 2, 3, 4, and out 2, I wanted to move my points halfway closer to this line that my vertex is sitting on. So it was 4 away, half of that would be 2 away. And you can see that's where my points ended up for my parabola. So that's a quicker way of doing it if you understand how it works. If not, you want to focus on whichever way is more consistently getting you the right answer. So 12, our vertex is -2 from the inside and -2 from the outside. And if we're making a table of values, we'd want to pick numbers that are close to -2, like -1 and 0, and -3 and -4. And then we'd find the y values that go with it. If you're wanting to use the transformations instead, you go to -2, -2, and then since there's nothing in front of here, it opens up because it's positive, and it's going to follow that pattern I was just talking about. We should go up 1 and out 1. Notice each square is a half, so that's why I'm going up and out 2 squares. And then I'm going to go up 4 and out 2. So 1, 2, 3, 4, and out 2. And this is what a normal parabola without a vertical stretch looks like. That number at the very front is giving me a vertical stretch or a vertical compression. Another word for compression is shrink. Some books use shrink instead of compression. So that's how we do it. There's one more here in vertex form. And then we switch to standard form. So here's our vertex, -1, -4. This time they are not going by 2s on our scale, and that's because we have a vertical stretch. The negative just tells us to make this open down, which we call a reflection. The 2 tells us that we are stretching by 2. So instead of going down 1 and out 1, I want to go twice as far down. I don't want to change the out at all. I just want to go twice as far down. So what's twice as far as 1? That would be 2. So here's my points. And then in a normal parabola that hasn't been stretched, we would go down 4 and out 2. So what's twice as far as 4? It would be 8. So here's 4, 5, 6, 7, 8. And I always count from my vertex, not from the 2 points that I drew after the vertex. So here's my parabola. You can tell that it is narrower than our other ones were. So there we go. These next 3 graphs I have are in standard form right now. So we're going to have to start by finding the vertex, and it's going to take a little more effort on our part. So we've got A, B, and C. So I'm going to do -4 over 2 times 1, which is -4 over 2, which is -2. Just like, whoa, what happened with that X and that line? Let's try this again. Just like with what was I saying? Just like with vertex form, you have 2 options. You can make a table of values, or you can use our transformation idea, because this 1 in front means that it opens up because it's a positive 1, and there's not a vertical stretch or compression because it's the number 1. If it's a number bigger than 1, it stretches. If it's a number smaller than 1, it compresses or shrinks. But with standard form, we do at least have to plug the -2 in. So -2 squared plus 4 times -2 plus 8. So 4, because a -2 squared is a positive 4. 4 times -2 is -8. So 4 minus 8 plus 8 equals 4. Now, if you want to keep going with the table of values, you would plug in some more numbers. And the cool thing about standard form is plugging in 0 is really easy, because if you put 0 here, and here, both of those things go away. This becomes 0 and this becomes 0, and it leaves you with 8. And that always happens. It basically just leaves you with the last number. So all we really need if we're making a table of values is to plug in either -1 or -3. I'm going to use transformations though to do that. So -2, 4, and then we've got 8 on either side. But I know that since this is not vertically stretched or compressed, that I just need to go up 1 and out 1. And here's my parabola. All right, 2 more. So this one on the left has a -1/2 in front, so we can already know before we do anything else that it opens down. And we also know that this is going to be a vertical compression by 1/2. We just don't know where the vertex is right now. And then on 16, well, no, I won't spoil it for 16. If you wanted to, at this point, pause the video and see if you can grasp this one yourself, that would be a great idea. So just play the video again when you're ready. So we've got a, b, and c. We're doing -b over 2a. So if you're putting the negative on top, we'd have -4, also known as a +4, and then 2 times -1/2. So these negatives can cancel each other out, or you can cancel out the negatives differently, but no matter how you cancel, you should end up with a negative left over, so this will overall be negative. On bottom, we want to do 2 times 1/2, which is 1. So if you have 2 1/2s, you have a whole, basically, is what that's saying. So since it's a negative, we'd put -1, and 4 divided by -1 is -4. So that's the middle number in our table of values. And then we're going to plug the -4 in and see what happens. So -1/2 times -4 squared minus 4 times -4 minus 4. So this is going to be 16 times -1/2, which is -8. And then -4 times -4 is +16. And then minus 4. -8 plus 16 is 8. Minus 4 is 4. So -4, 4. So as I mentioned earlier, this is opening down and is a compression by 1/2. So this is going to do the same thing as what we saw earlier, that instead of going down 1 and out 1, I want to go out 1 still, but only down 1/2. I want to go halfway down to where my normal points would be, but still go out 1. And instead of going down 4, out 2, which would be here, I'm going to go half as far. So that's going to be here and here. And now I'm going to draw this parabola. All right. So 16, same deal. If you want to pause and see how you do on your own, this would be a good time to do it. The 3 in front is telling us that this opens up and that we're going to have a vertical stretch by 3. So it's going to go up really fast. We would we would write -b, so -12 over 2 times 3. So -12 over 6, which is -2. I'm going to plug that -2 in. So -2 squared is 4. 4 times 3 is 12. 12 times -2 is -24. And so I get -12 plus 10, which is -2. Pro tip for all you out there, a nice math hack for these types of problems, is that if what you get when you plug it in gives you too big of a number, but you're confident about this math on your second part, try changing the sign of your vertex. One of the most common things that you can mess up here is messing up this sign, saying it's a positive when it should be a negative, or vice versa. So it doesn't hurt to just try if you can't think of what else might be going wrong. All right, so we've got a vertical stretch of 3. So instead of going up 1, out 1, we want to go up 3 times as fast. So up 3, out 1. And then our second set of points we get from going up 4, out 2, but we want to go 3 times as far. So 3 times 4 is 12. So from this point down here, I want to go up 12 and out 2. And so you can see this is a really, really narrow parabola. And it did end up opening up. Oh, I guess I drew it so it opened up. So there you go. Now we've got just a couple more types of problems to look at. This problem says what transformations are happening to the graph of g of x equals, and it gives us an equation, from the parent graph f of x equals x squared. I provided a graph in case someone really wants to just graph it and see, because you can see the transformations even if you're using a table of values to graph. But we're essentially comparing to that normal parent graph that we go up 1, out 1, up 4, out 2 from 0, 0. So we're saying, how do I get this from, that's a really terrible looking parabola, pretend that looks better. How do I get that from if I have this equation instead? So the negative at the front, this negative means that this opens down. We call this a reflection over the x-axis. And you are attempting to learn some math language here. This is our technical way of talking about this. The negative means we're going to reflect over the x-axis. So if all I had was that negative in front, it would tell me that these points reflect down over the x-axis. The 2 in front, and I'm going to think of this separately from the negative, the 2 is a vertical stretch by 2. And we saw that in action earlier, that we are taking each point and we're making it be twice as far as it normally would be. The plus 2 inside, part of the super secret opposite side society, means that this is going to go left 2. You know it's left or right because it's inside with x, and x is left or right. Look at the x-axis here. But instead of plus 2 meaning to go right 2, it's the opposite. So we want to shift left 2. Then finally the minus 3 at the end makes us shift down 3. And so those are our 4 transformations on this one. That's the most, well, I guess it's not technically the most we could have, but that's as far as we're going with this. So on 18, same idea, except we don't have a negative in front, so there's no reflection. The 1/2, instead of it being a vertical stretch of 1/2, which doesn't make sense since it doesn't stretch if it's a fraction, we call it a vertical compression by 1/2. And then the negative 4 means to go right 4. And the plus 1 means shift up 1. So we have to identify, like, each of these spots has a thing. If it's in front of your parentheses, it's telling you whether it's reflected or not, and it's telling you whether it's a stretch or shrink. If there's nothing in front, neither of those two things are happening. And what's inside of our parentheses here is telling us a shift left or right, but opposite of whatever this sign would normally make us think. And outside at the end here, it's telling us shift up or down, but it's not the opposite like the inside was. 19 and 20 we're solving by graphing. So what this does is it adds a step. What we want to do is still graph this like as though it was equal y, but our answers are going to be where this crosses the x-axis. Or if it doesn't cross the x-axis, our answer would be no solution. So this is in vertex form. Our vertex is -4, -2, which is right here. There's a vertical compression of 1/2, so we'd go out 1 but only up 1/2, so that'd be in between our squares here. And then our next points, instead of up 4, out 2, we want to go half as far up, so up 2, out 2, which is convenient because that's touching the x-axis. Our graph does go through it, but what we care about here, what we're going to say x equals, is x equals -6 and x equals -2. And these are two answers for this equation. And what that means is that if you put -6 where this x is, and you work out the left side of this equation, you should get 0 as your answer. And also, if you plug in -2 where x is, and you work this out, you should also get 0 as your answer. So we're basically using the graph to figure out the only two numbers that when we plug them in give us 0. 20 is in standard form, so let's start off by getting the vertex. So negative b over 2a, so -4 divided by -2, which is +2, and then I'm going to plug it in. I was wondering if this happened anywhere, and so I guess I'm glad that it did, to make sure that we talk about this. I do need to plug 2 in. I'm going to ignore the equals 0 for now because I'm trying to graph this. When I plug in 2 and I'm being asked to square it and then make it negative, that is that situation on our calculator that I was talking about earlier. Let's say enter there. Okay. That's the situation where we're saying -2 and we're squaring it. We actually want it to do that because we're saying, hey, square that 2, but then make it negative, which is -4 and not +4. And that's an important distinction to be able to make between those two ideas. So we were supposed to square it, but then make it negative because it's a -x squared. So this is 4 minus 3, which is 1. So over 2 up 1. And then this is opening down because of the -1 in front, but it's not being vertically stretched. So we're going to go down 1 and out 1. And then down 4 and out 2. This goes through at 1 and 3. Now, that's on purpose that I picked things that it goes through nicely. There are times where it'll go through and seem like it must be some sort of fraction or decimal. And if all you know how to do is solve by graphing, you just have to approximate it the best you can. There is a situation that could happen, and if you look back at your parabolas, you can probably find a situation where this happens, where you can have a parabola that has no solutions, and that happens when, for instance, your parabola opens up but is above the x-axis. Look, it doesn't even touch the x-axis. But there's actually so many different ways you could draw this. As long as your parabola doesn't cross the x-axis is fine. If you drew this, though, this would not be fine, because just because you didn't draw it through the x-axis doesn't mean it wouldn't go through. So that's not okay. You want it to be, if it's above the x-axis, it's going to have to open up in order for it to have no solution, or if it's below the x-axis, it's going to have to open down. So those are like 4 different places where that would work. Finally, we have a word problem here. Word problems are great because they show us exactly where our math would be used in the real world. So we've got a soccer ball, and the height of it in meters when it is kicked is modeled by h of t equals -5t squared plus 20t, where t is the time in seconds. Part A says graph the function. So we've got a, b, there's not a c, but we don't really need c. If we did need c, c would be 0. And so when I plug this in, I get -20 over 2 times -5. So that gives me -20 over -10, which equals 2. So the x value of my vertex is 2. And so I plug that in and I get 4 times -5 is -20 plus 40 is 20. So my vertex is 220, which, by the way, it asked me what the vertex is on part C. So 220. Now this opens down. It says -5. So I know it opens down, and I know that I want to go down 5 and out 1. Now out 1 is actually out a square, but down 5 from 20 does not mean go down 5 boxes. It would mean go where 5 below 20 is, which is 15, which should be halfway between 10 and 20. So here and here. Or another way to do it is if you plug in numbers, you can get the values, and that might be easier in this case. It certainly is easy when you plug in 0. When I plug in 0, I get 0, and then I just have to mirror that onto the other side. So here is my parabola of this soccer ball I kicked. And part B says, how long is the ball in the air? Well, I kicked it at time 0, and it went up in the air, and it came back down, and we're saying that it landed at this right here, 4 seconds. So 4 seconds is how long it's in the air. And then part C says, find and interpret the vertex of the graph. So I found it. It's 2, 20. What does that mean in this situation? The 2 is talking about time, and the 20 is talking about height. So essentially our vertex is telling us that at 2 seconds the ball will be 20 meters high, which is the highest point that it reaches. So something to that effect. So at 2 seconds the ball is at its highest point, 20 meters. So something to that effect would be an appropriate way of writing that question. Hope you enjoyed this video. If you did, please like, subscribe, comment, tell me how your test went after you took it, and best of luck to you.